Let me start by presenting Dr. Ahmed Adel, and he's one of, as I said, one of the brightest engineers in Egypt and inventor of Dent1 3D printer. Hello, Dr. Ahmed.
Hello, Dr. Ahmed. Hello, everyone. Thank you for kind introduction, and thank you for having me.
Okay, you can start your presentation, Dr. Ahmed, and tell us what is your presentation about today.
Awesome, thank you. Yeah, the aim of the presentation today is to give a briefing about the 3D printing industry and how it works in dental practice. Let's start by introducing myself and the company and a strategic or the bigger picture of the 3D printing industry in the dental field. I'm a CEO of MOGASSAM. MOGASSAM is digitizing the dental workflow based on 3D printing, and this is how it works. We are substituting or disrupting the 3D printing generally, disrupting the way of making prostheses, aligner, models, or implants by allowing the average dentist to do as a super talented dentist, relying on the digital tools. The traditional workflow starting by manual impression, then the dentist has to pour the stone mold should ship to the lab to fabricate handcraft porcelain crown. Then it's seated on a stone mold that replicate the patient mouth, and after then the lab send it again back to the dentist in the clinic office. It takes 5 days and $160 to fabricate a handcrafted crown that might work or might require another rescheduling another visit. While what is a 3D printing offering for a dentist is to provide a digital workflow, scan, design, and print within one visit, and it only costs the direct operating cost. This is not the total cost. The direct operating cost is only $1. Right now, the state of art of 3D printing is viable for a single unit crown, or on day single unit is viable for a 3D printing. It allows us as dentists to fabricate our crowns within one visit and save more than 100 times of cost. Usually 3D printing workflow, the solution consists of software, which is a CAM software that prepares the files to be printable, and hardware, the 3D printing workflow, and it's supposed to use FDA approved medical grade cartridge. And for every application, starting from clear aligner and permanent crowns, surgical guides to allow implants place their implant, or GPs place their implants with a proper orientation and without hitting the nerve. The surgical guide is a medium to allow dentists implement their virtual plan in real life. And veneers, digital wax, and also denture bases and dental models. This is the application that deployed for the 3D printing workflow, and each application should use a specific cartridge. So far, the dentistry roadmap, there are 1 million dentists in the world. Only 7% of them who are into printing workflow. And why it's growing 29.3% year over year. There are still 93% of us who are relying on traditional workflow. The reason for that is a learning curve. There are a lot of 3D printers. As dentists choose the 3D printer, it's better to be affordable and a dental printer, because there are the 3D printers starting from $100 to $1 million. To find a great printer, it's supposed to be affordable and also dental. The CAM software requires a lot of steps. Sorry.
Yes, continue, Dr. Ahmed. No problem. You can continue. It's okay.
Okay. Many of 3D printers requires a lot of steps to prepare the crown to be printable. Usually, we are looking for one-click crown. As a CEO of MOGASSAM, and we worked hard to provide a one-click printer. With 30% of our last products or our last versions, 30% of the failure rate of printers or last generation was about the software or file preparation on a CAM software, as it requires a 40 step from importing, manual orientation, generating support, manually editing supports, and that's why we worked to build a software that only require a one-click printing, and it works in a way. It works in a way that based on AI, artificial intelligence, and also the software understand the anatomy of the crown, like where is the fitting area, where is the occlusion, where is the mesial, where is the distal view. So software understands this. That software that AI assisted understand these views and accordingly do a proper automated orientation and support generation. And also on the hardware side, there are challenges. To print a crown or a model or a surgical guide, it requires a printer. Here we are talking about a resin-based printer, and then washing and post-curing. The post-curing is a stage where the printed part exposed to extra dose of UV, of ultraviolet, to assure that 100% photopolymerized or 100% polymerized, to be complied with FDA approval process for each application. So the post-curing stage is mandatory to be complying with FDA approval regulation. Also, at MOGASSAM, we were facing a lot of the challenges in the post-processing, and also 30% of failure rate were coming from post-processing. In our new product, we tried to implement or combine the whole workflow in a desktop machine, just next, to get your crown printed and ready. So also other part of printing workflow is, yeah, in Mogassam we implemented all-in-one solution. This is always good to find all-in-one solution. Either it's compact or combined in a desktop machine like Mogassam solution, or even distributed like many of other companies. But it's so mandatory to find a complete solution of printing and washing and post-curing. Also, the accuracy is super crucial. And here you will find a lot of numbers that represent nothing. To choose a proper printer, you have to understand the difference between resolution, accuracy, and the resolution, because the resolution is always a confusing term with accuracy. Resolution, by definition, it means the minimum feature that could be printed. So when we are saying 25 micrometer resolution in z-axis, it means the smallest layer or the highest definition layer that could be printed in z-axis, which represents the layer thickness, is 25 micrometer. But it doesn't mean anything related to XY resolution or the accuracy. And when we are saying it's 50 micrometer in X and Y, it means the minimum feature size in X and Y dimensions is 50 micrometer. Why in the combination of 25 micrometer Z and 50 micrometer X and Y, the accuracy could be 200 micrometer, because it depends on the kind of resin, the stability of mechanical system, the uniformity of light, the degree of distortion in the optical engine. These parameters are defining the accuracy. And for end user or a dentist, you can get sample from the company, just sending STL file and ask for a printed sample, and get this sample, do a scanning, and comparing the scanned data with the printed model. And you can use the GeoMagic tool. It's called alignment or superposition, or also if you are a Medit user, there is a superposition or alignment add-on or tool to help you find the difference between the original scan data and the 3D printed sample. Another part to look for in choosing the 3D printer is a vertical integration workflow. One of many challenges that we were facing previously was the integration part, because the scan data is not printable. Exporting a design file that's not printable, like for example the model and the die. There is a difference between the model and die. It's called a tolerance or a clearance gap. The clearance gap, it depends on the printer and the kind of resin. So every printer in the world has its own clearance gap or tolerance, and it's different from resin material to another. So it's very important to find a solution that vertically integrated with the scanner company to assure that this scan data could be printable, and also with a CAD software company like ExoCAD or 3Shape to assure that you are designing for manufacturing, you are designing for printing, and also the time. Time is a really great parameter, and maybe 3 years ago there were no enough materials in the market, but recently there are a lot of material, and also there was an issue in reliability. Right now, the printer companies have solved a lot of their reliability issues, but the main parameter right now, the main differentiation right now is time, because it allows you to print within one visit, or within same day, or within 1 week. Yeah, that these are the main points on the strategic side, while on going dig deep into how these things works. Yeah, this is the main issue to find, or that's why we in MOGASSAM at least we are looking for to integrate our printers with other software and scan. Just give me a second, please. After the 3D scanning, the scan data requires a repair because it's not so uniform, and it's exported from the scanner in a surface way, or as a chip, not a solid model for printing. And there are a lot of holes, and to do 3D printify, it requires to be a watertight. But the scanning data, it's exported from the scanning software in a surface form with holes, and it's not uniform. So suppose to go for another step, which is repairing, to fix any hole, to be watertight and solidify. And after solidifying, it's better or recommended to go for hollowing. The hollowing is minimizing the volume or the amount of material that's used for printing to save cost. Then you will go for CAM software. I will share with you a demo to understand how it works. Here we go. This is a CAM software. Say, printing demo. Say, just choose the name, choose the printer in your network. If your printer is using Wi-Fi, like here in MOGASSAM or machines are based on Wi-Fi networks, choosing the machine name that's connected right now. Then moving to choose the materials, the appropriate material. I can go from this page. Then the layer thickness, and go for dropping some files. There you go. Just arranging this file, starting by moving manually. You can move your parts manually, like here, and that's it. Once it's imported, this box, this 3D volumetric wireframe or boundaries is representing the building volume. Outside this volume, you can't go outside this volume because it's not within the printing printing area. And to check that your model is placed as you want, just go for some views, check your files. And after then you can go for checking orientation. Here it works with is there orientation works well. If it doesn't work well, like 6 here, it's not oriented well. In model we are selecting the base, like here. And then if you want to go for support generation, you just go for another button. So we did a rotation, we did a movement, translation, and rotation. We make the orientation a bit oriented to try support generation script. And let's go for support generation. The main parameters of support is density, the contact point. The contact point is important to assure that it's very well placed with model to not go away during reading. So it's in a great contact with a 3D model. So as you make the value bigger, you are assuring success rate of printing. However, it makes a scar or after removing it in the printing. So it's the optimum value here is 0.25. That assure there are no failure print, and also leaving the part without scars. And the base thickness of supports, and also the shortest support. What is the height of shortest support? Then go for generate. That's it. Usually at MOGASSAM and also many dental companies, you don't have to interfere with this value. It's automated. Just use the default value, and everything will go away. Yeah, here you are ready for printing. Let's press the print button. And then the file are uploading to the printer. Some other functions are nice, like draft. At the draft, you are choosing. Here we are printing at 100 micrometer. Working with 100 micrometer is great, gives you a great speed, but also we are consuming time at the printing of supports at 100 micrometer, and we don't need high resolution for supports. So what we do, we are choosing the set to shortest support height. So at the draft speed, we are setting, we are selecting all the supports to be printed at a lower quality, like 300 micrometer. So you are getting a lower resolution at the parts that's not affecting the function, and also getting the speed. So to optimize the speed a little bit. Yeah, then once you press print, the file is uploaded to the machine. Okay, here's a breakdown of how printing works. So printing consists of, in DLP, consists of projector, downside, and tank, what's so-called the vat, and this vat filled with a liquid resin. And there are a mechanical movement in the direction using the platform. These are the main components in 3D printing: projector or optical engine, and tank to hold the resin, and a mechanical movement coming from a build platform. And this is in the initial condition. Then the projector, after we prepared our 3D model to be printable, the slicer is sending the files in a sequence to the projector to be projected at the tank, while the build platform go to trap a 100 micrometer of resin to be exposed to the projected UV. Projector work starts to expose ultraviolet to 100 micrometers that's trapped under the build platform, and after the curing time ends, the separation starts to allow the build platform to go a little bit for another 100 micrometer, and to prepare for another slice. So projection, separation, the build platform go up, and then retraction, the build platform go back again, and starts to repeat. The projector is going to project the new layer, but here you notice that the two layers with different geometry, and keep repeating till you will find your crown is ready for is completely printed. As we are talking about a resin-based 3D printer, it's not only DLP, like the projection we were talking about. There is a technique called SLA or DAP or LCD. The SLA technique is relying on the laser. The difference between these techniques is the optical engine, the source of ultraviolet, how it projects or how it works. In SLA, it's relying on laser. On DLP, it's relying on a projector, like a home use projector, but it works with ultraviolet source. And it's so similar for LCD. LCD super similar to our phone screen. However, the backlight is not a visible light; it's ultraviolet light, but it works in the same way. Pros and cons: the laser is not limited with the building volume. You can the companies that are using lasers, it can provide a higher building volume, but it's slower. DLP and relatively low cost. DLP is much faster, but the cons is a low building volume. Usually, it's a low building volume and a high cost. But you are getting a high accuracy, high durability, very high printing speed. The SD is highly low cost, the cheapest technique, and it works in the same way as a projector, but the light intensity of LCD screen is very low, which lead to a slower printing time. After then, you go for washing. It's highly recommended IPA, 99% alcohol, to clean the printed part from residual monomers that's still sticking to your printed crown or guide or model. So go for washing, remove any resin residuals. After then, go for UV post curing to complete to ensure that 100% of polymerization takes place and it's complying with FDA approval process or regulation. Yeah, and that's why we at MOGASSAM we have built a dent case printer that's combining the printing and washing and post curing in a compact disco machine. Just next, your job is done and ready for patient loss. Thank you, and I would love to hear any of your questions.
Thank you, Engineer Ahmed, for the nice presentation. And of course, it's very beneficial, especially for a beginner and someone who likes to start his career in the digital, starting with a 3D printer. But let me ask you about the future of 3D printing, especially the zirconia. Do you believe that zirconia will be available? I know it's available, but when do you expect that zirconia will be just 3D printed, not milled?
Yeah, that's a great question. Yeah, as you mentioned, Dr. Am, the 3D zirconia, the printed zirconia is existing, and there a commercial printer that's available in the market called the Lithos. Lithos is printing zirconia, but it's a very high cost. Their price is $400K US. I believe it's a matter of time. The same as happened, or using the analogy of surgical guide. In 2500 or even 2006. The surgical guide, to print a surgical guide, you need a printer for $100K US. But in 2014 or 2015, you can get a printer for $500 and print your surgical guide. It takes 10 years in surgical guide. It takes 10 years to let the cost drop down. I think within 3 or 5 years, as already the printing technology is very hot in dental market, and there are a lot of research that happened in the last 10 years. I think 3 to 5 years, and the 3D printed zirconia or the zirconia will be printed, will be manufactured through 3D printers. But also, we are expecting a new kind of material, not only zirconia or the popular material in the milling machines. We are expecting a new kind of materials, the printable, and also giving the same mechanical properties and aesthetics and physiological properties. And also we have Bigo produced their own resin material that's permanent restoration for single crown. We can't say this material is Emax or zirconia but it's a resin microfield hybrid material, and it's complying with aesthetics and physiological parameters. While in mechanical pipettes, it's relatively weak as it's 150 megapascal. But yeah, there are a lot of research, published research right now that reached 300 megapascal flexure strength and even 500. So I'm expecting it will be within 3 years, and we will have a more reliable and durable printed permanent restoration.
Okay, my next question. Do you think if metal printing became more feasible and cheaper, that CAD/CAM milling will be history in the near future?
The near future?
Maybe I think CAD/CAM will be history one day. Do you think so? Or we still will have the printer on the side and the CAD/CAM on the other side?
I think, yeah, it will be a history as a chair side. But I don't think it will vanish in the near future for dental labs. Like what happened even between the zirconia and a commercial material called Emax, or a commercial name of the material called Emax. The CAD/CAM adopted the adoption in clinics for Emax, but when it comes to zirconia, the dentist mostly is relying on the lab, or even the CAD/CAM, the chair side CAD/CAM works well for 3 units, 1 to 3 units. But when it comes to full arch, the dentist is relying on the lab. I think the same will happen with the 3D printing and CAD/CAM. There will be a new kind of CAD/CAM that for a very high production, and it will be used in a central lab, on a centralized lab. This kind of lab is not the same as we see right now. They're producing 100 units per day or 200 units per day. It will produce 50K or 100K units per day. So I think the lab business will be consolidated in a few central labs, and these central labs will use a new kind of CAD/CAM for a very specific cases. But I believe the 3D printing will be more adapted in the clinic and the small labs, and the very specific a few cases will be manufactured through CAD/CAM in a very few central labs.
Okay, you named the term chair side CAD/CAM. Do you believe that we will have a chair side 3D printing?
Yeah, definitely, yes. Yeah.
Okay.
And also, yeah, even at MOGASSAM, we are working super hard to deliver our new chair side 3D printer. Yeah.
I think you're the only. Yes.
Yeah. Sorry.
I think you're the only printer that you have the 3-in-1. You have the washing, curing, and of course the 3D printing in just one confined printer. Is that right?
Yeah, this is right. Sorry. Also, there are a company called the Structo. They announced the new product, but so far they are not even talking about it. But maybe it existed in their pipeline. But yeah, MOGASSAM and Structo, the only companies who are working on who are providing one all-in-one solution. Because yeah, the main challenge for chair side, answering your question, the chair side 3D printer, yes, it's very valid, and even it's more valid for more than CAD/CAM due to the cost. And also a huge development that happened in materials. Before COVID, we didn't have a permanent restoration. Right now, we have a permanent restoration material that makes the printer is more feasible for a clinic as a chair side. But the main challenge right now in printers, the speed and usability. In the present world, we don't have an easy-to-use printer. Like what happened in CAD/CAM, by CERIC or by Dental Supplies owner, as they provided the CERIC. Once they provided a very easy to use solution and fast, like next, your job done, a wizard user experience. The CAD/CAM a highly adapted in the clinics, but right now this milestone didn't happen in the 3D printing. But this is what we are doing at MOGASSAM, actually, to make the 3D printer in every clinic in the world. So I believe so. Yeah, definitely yes. It will be widely spread as a chairside solution in a very near future.
Yes, we hope so. Thank you, Engineer Ahmed. It was my pleasure having you today, and thank you everyone watching. And have a great day. Thank you, everyone. Bye bye.
Thank you.